Hi everyone, welcome back. My name is Ananth, and today we're going to be going over recursion. So recursion is nothing more than a method that calls itself to solve a smaller piece of a larger problem. And we have a quick visualization of that right here below, where we start off at the top with n equals 5, and we recursively solve this, whatever the problem is, with calls all the way down to n equals 0. And recursion is particularly useful in hierarchical and repetitive problems and simplifies the amount of code we have to write when it's just going to be the same thing with different values. The structure of recursive methods has to do with 1, a base case, which stops recursion, and 2, a recursive step, which continues recursion, but reduces the problem based on some parameter and calls the same method again. This is an example structure of a recursive method where we accept a parameter, and if this parameter meets some condition in our base case, we return a value, and if not, we return a recursive call to the same method after reducing that parameter. Now that we've covered some definitions, we'll do some practice, writing a recursive function to compute the factorial of a number. All right, now that I've made it to Eclipse, I'll get started with the factorial method. So I'll first write the method header, public static int factorial, and we'll accept an integer n, and we're going to be computing the factorial of whatever this integer is. So if we were to accept, 3, then we want to compute 3 factorial, which is equal to 3 times 2 times 1, giving us 6. And first thing we always want to think about when we're defining a recursive method is the base case. So in our case, the base case would be when n is equal to 0, in which we want to return 1, because we know that 0 factorial is always 1, and we cannot go into the negatives. Now, if this base case is not met, we want to think about what our problem is and how we can break it down into smaller steps. So if we start off with just accepting n is equal to 3, and we want to recursively solve this, we know that we want to compute 3 times 2 times 1. So instead of just doing this using a for loop or any other method we've seen so far, recursion is going to look something like this, where we return the value n times the result of the method call for factorial n minus 1. And this should be it right here, except for this little typo. And now that we've defined this, we can test it out in the main method. So I'll say print factorial of 5, and we get the correct answer of 120. Now we know that when we call factorial 5, that we're computing 5 times 4 times 3 times 2 times 1, but what's actually happening under the hood is we start off with 5 as n, we return 5 times factorial 5 minus 1. So initially, factorial 5 is pushed onto the call stack, then we push factorial 4, factorial 3, factorial 2, and we continually do this upwards until the base case of n equals 0 is hit. Then progressively, each one of the method calls is popped off the stack, and the total value of 120 is returned. Now that we've defined everything and had to do some practice, I'll do a quick recap for ending the video. So recursion is nothing more than a method that calls itself. But one thing that we know now is when a method calls itself recursively, it is pushing these method calls onto the call stack, which progressively get called up. And after hitting the base case, which stops all future recursive calls, everything is popped off and we are left with our final result. That's all for today, and I'll see you guys in the next one.